Hello and welcome to our August Knosh and No panel discussion. I am Debbie Reese and I'm going to get our speakers all set up here. Stephanie, you are now able to talk.
Great. Can you hear me?
Yeah. Go ahead and turn
Awesome.
on your video if you can.
It's not giving me the option to do video.
Let me see. Let's see. Well,
That's okay. I can just,
panelists.
as long as Kevin, has access to do the presentation, I can just chat, introduce him via voice.
Okay. I think I've promoted you to panelist, so you should be able to turn on your video maybe. If not, that's okay.
Yes, here we go. Hello, everybody.
Oh, welcome. Good to see you.
Yes, you too. All right, so I guess we'll go ahead since we're a couple minutes late getting started here. I'll just jump right into it. So I'm Stephanie Horner. I am with Applied Technical Services, and I'm local here in Denver. Maybe some of you know me. And we are going to be giving a presentation today on fall protection and suspended access equipment, mainly used by window washers and roof contractors, as well as other facade maintenance contractors. Giving the presentation today is Kevin Scurry, who is our Colorado PE. He's actually based out of South Carolina and works for our headquarters in Atlanta, but he does travel here quite a bit and covers all of our Colorado work. So Kevin will go through some slides and he's got some questions. You guys can participate in the chat option, and I will be reviewing the chats with the group here. So with that, take it away, Kevin.
Kevin, you're muted.
See, there we go. Is that better?
Yep.
All right. I told you I was going to have some hiccups here doing the first virtual presentation. I appreciate everyone joining today. Good morning to you, good day, good afternoon, depending on where you are. I know most of you guys are probably out of the Denver, Colorado area. As Stephanie mentioned, I'm a structural engineer with Applied Technical Services. I'm a licensed Colorado professional engineer. Been working in the fall protection suspended access industry for about eight years or so now with Applied Technical Services. Before that, I've done design for just about any type of building structure, anything from 1 story up to 50 stories all over the country. And now, like I said, I specialize in fall protection equipment. And so our presentation today, normally when I give this presentation, it's geared around a lot of architects and other engineers who are in the design industry. This particular presentation for those of you folks who are dealing with facility management, building engineers, property managers, I've tailored this presentation more to you guys to understand the various methods and techniques that are used to access facades for routine maintenance, particularly window washing when we talk about routine maintenance. And I've also got some information in there about fall protection as well, things that are probably common to a lot of your properties and facilities out there. So with that, we'll jump right in. Like Stephanie mentioned, she is going to be monitoring the chat section of the meeting here. So if you have any questions, drop a line in the chat section. I also have some questions as well as we go along, just kind of participate with everybody. Nonetheless, we'll get started.
Kevin, did you want to share your screen?
Yes, is it not sharing? Let's see.
No.
All right.
There you go.
Okay.
Perfect. Thank
Good
you.
to go. Okay, so just to give you a little brief introduction of Applied Technical Services. The best way I can put it is we are a large company, very large company, multiple locations across the U.S. that have our hands in many different aspects. And when I say many different aspects of things, we are an engineering, testing, inspection firm, and we simply put, we test, we inspect, and we provide engineering consulting for a wide range of things. And what I mean by that is, with our next slide, this is this is actually kind of a joke for me, but we're such a big company. I took this screenshot from our website. When you go to our website, atslab.com, you can immediately see the different areas, the various areas across the industries, professional industries that we tailor to. And so we have our hands, like I said, in on all kinds of things. Particularly the division that Stephanie and I work in, we call it commercial services. And you see it circled here as commercial properties. And what we deal with, predominantly 95, 99% of the time is commercial properties. We're dealing with your facade access equipment. Again, just a fancy word for saying window washing equipment or your maintenance equipment. These are roof anchors. These are davit arms. With that, there's other fall protection equipment on the roofs as well. And we'll look at all that sort of stuff and how that plays out with OSHA regulations, which is law, and industry standards, which are best practices out there. We've been around for about 50 years. We have been doing fall protection and suspended access equipment. We've been involved in this industry since the early 90s. And again, we've been doing this all over the country. As a licensed engineer, I am registered in about 32 states, I believe. I have a couple other colleagues who are registered in some various other states. Altogether with ATS, we are registered to practice engineering in 40, I believe it was 42 or 43 states out of the 50. So again, we're very diverse and can do just about anything. Give you an idea of where we're located. Our headquarters is out of Marietta, Georgia, in Atlanta, which is where I'm based out of. I do work out of my home in Greenville, South Carolina, when I'm not traveling on the road. But I do manage the Atlanta office as well as our Houston location that does commercial services. We have another location, Alexandria, Virginia, just outside of Washington, D.C., that does this work as well. Between our Alexandria, our Atlanta, and our Houston office, as well as Denver, I want to forget Stephanie out there. We need to get her here on the map. But we do have, obviously, a presence in Denver now, and we've been out there for, I want to say, at least 5 or 6 years now. Steph, correct me if I'm wrong, but I think we've been out there for about 5 years. Yep. So between Houston, Alexandria, and Atlanta, and Denver, those offices pretty much service the entire U.S. And I will add abroad. We do have some projects in Canada, as well as some in Mexico right now, ongoing. When I give this presentation, I'm gonna skip over this, but when I give this presentation to my architects, because of their AIA requirements, the Architect Institute, we're required to go over the course description and present some of those, the learning objectives here. Similar to what we'll be going over today, federal regulations and OSHA standards regarding fall protection, suspended access equipment. Again, I'm also going to touch on the inspection, testing, and certification requirements of that equipment, as well as the various types of equipment out there that you guys may see on your properties, or what's most common. And then what's kind of required of ownership, you guys as being facility managers or property managers, as well as user requirements. That could also be you guys as well. If your building engineers are using these systems, the fall protection systems, particularly on your building, in those situations, you are the users. In other situations, your user is actually going to be your contractor or your vendor who's coming on site to gain access to the roof or wherever this equipment might be. So my first question, just kind of get everybody warmed up here and get everybody involved, is does your property or facility have some type of fall protection or suspended access equipment currently installed that you're using annually? So we'll just take a minute or two, if you will, to answer just quick yes or no. And again, as we're getting the answers in here, as people are selecting their answers or posting their answers, as things come up during the presentation, if you see a picture, something you see in a picture, something that, again, you have a question with that relates to that slide, don't hesitate to throw that into the chat window. And Stephanie will let me know. All right, so right now we've had 4 participants, and it's actually 50-50 with yes or no. So out of the 4 participated, 2 of you have some type of equipment, and 2 of you do not. Get back to my presentation. Okay, so when we deal with suspended access and fall protection equipment, we like to break it down from an engineering standpoint when we talk to our clients about regulations, federal regulations and standards. We want to decipher the difference between those. And the big difference is that federal regulations, OSHA regulations, are federal law. They are requirements. There is no, do I have a choice or not? You have to do, to be compliant with law and be compliant with federal regulations, you have to do what OSHA states as your requirements for the equipment. Whether that's requirements of how the equipment functions or operates, or even the use of that equipment, or the design behind that equipment. So OSHA, again, is federal law, and those are the requirements that you have to do. Industry standards or national standards are best practices and recommendations that are nationally recognized standards by some entity or organization, some professional entity or organization. And these are best practices that are recommendations on better ways of using the equipment, better ways that it can be designed or operated. But what you will see is that a lot of the OSHA regulations, if not all the OSHA regulations that deal with suspended access and fall protection equipment, as do many of the OSHA regulations out there, they are really cut and paste verbiage from a lot of the industry standards. OSHA picks and chooses from the various industry standards what they want to apply as far as their regulations. And then there's obviously, you know, again, what we call the best practices, or what's left over that stays in the standard. Doesn't become requirements per OSHA, but it is recommended as best practices. And when I say that, or why I say that, because OSHA has the ability, when they come out on your property, when there's an incident and they're brought out on the scene, OSHA has the ability to reference, even though they may not specifically call out a requirement in OSHA, they do have the ability to come out and cite and fine you for you not meeting a national standard. And the way that they are allowed to do that is under the general duty clause. And what OSHA's general duty clause basically says is that as an employer, your job is going to be to provide the safest workplace to your employee. And so at the end of the day, while OSHA may not have it written down as regulations, they could come out and find something on your property and cite you or fine you or penalize you for that based off of a reference standard out there. So we have seen that in the past, so just keep that in mind. So when we deal with the suspended access and fall protection regulations under OSHA, you're particularly dealing with the first 4 that we have listed here. You'll see the common numbers is 1910, That 1910 deals with general industry regulations. The other common number that you may be familiar with is OSHA 1926. And in 1926, that applies to construction industries and regulations. So there's a little bit of difference there. General industry deals with, for commercial properties, it deals with the building maintenance, and it specifically deals with window washing. And so the 4 regulations that OSHA that falls under for what we're talking about for suspended access and fall protection equipment under the general industry is OSHA 1910-27. This regulation was introduced in January of 2017. Hopefully many of you are familiar with that already. In this particular regulation, OSHA addressed rope descent systems. You'll hear me call that RDS for short. Rope descent systems is when somebody washes your building using a bosun's chair, a bucket, and a squeegee, and some ropes. I'll show you a picture of that. They're simply rappelling down the side of your building, washing the building. 1910-28 deals with your fall protection and duty to have fall protection of falling objects. So this is the regulation that deals with holes in the floor, unprotected edges of a roof, fall hazard situations, and how you have to address those as an employer. 1910-66 deals specifically with powered platforms and scaffolding on your building. This section particularly applies to you if you own the powered platform and it is owned by the building and is permanent property or permanent equipment for the building. And then 1910-140 deals specifically with personal fall protection systems. This is the requirements for body harnesses, lanyards, safety fall protection devices, connections, components, carabiners, all the connections that go between the body harness to the actual fall protection system, and the requirements and design behind those. Then when we deal with the standards of the regulations, or the national standards that influence these regulations, you'll see things like the ANSI standard Z359, which is the American Society of Safety Professionals, the ASSP. This is your fall protection code. The ASME A120, this is a safety requirements for powered platforms. Also deals with traveling ladders and gantries, specifically used for building maintenance. And then the IWCA, we call the I-14, which came out in 2001, which addresses window cleaning safety. So those are the 3 standards that have over the years influenced the 4 OSHA regulations you see above there, how those have been written. So again, just to decipher the difference again, federal law, federal regulations is law and required. The standards are best practices and recommended to be done. So we talk about how to clean the building. There's typically 2 ways of doing that. There's rope descent systems, again called RDS. Here's 2 examples of that. Again, it's a person that simply is suspended off of ropes. They're hanging over the side of your building with a bucket and a squeegee. They're sitting in a bosun's chair, and they're washing the windows as they rappel down the side of the building. What you'll notice in the 2 pictures that I have here, and it's kind of a little more clear in the right-hand corner, upper right-hand corner with that gentleman there, is you'll see a series of 2 ropes that he is suspended from. One rope is called the primary. The second one is the secondary or lifeline. Each of these ropes is hooked to a separate independent anchor on the roof. And I'll show you a picture of that in a minute. But this is a system of redundancy in that if one rope or one anchor was to break, there's a backup rope and a backup anchor, system of redundancy, so that the person does not fall to the ground. Rope descent systems are typically the most cheapest and economical way to clean and maintain your building. And that's typically due to the amount of labor or really the lack of labor it takes and the amount of equipment. You only need roof anchors on your building. And then the window washer brings his ropes, his body harness, and his bosun's chair. to attach to your roof anchors that are permanently installed on your building. With rope descent, if you're doing it over 130 feet, you have to be stabilized, which is typically a suction cup. You may have seen this on your buildings before if you have a building that's over 130 feet. And with the regulation that OSHA introduced in January of 2017, specifically dealing with rope descent systems, the 1910-27, in that regulation, OSHA capped RDS procedures at 300 feet from grade. And at ATS grade, we take that as ground. So 300 feet from ground, if your building is taller than that, you're not allowed to use rope descent systems. And typically, if your building is taller than that, you already have, in most situations, you already have other types of equipment on the building. We'll look at some examples of that, but you have other types of equipment that will allow you to do routine maintenance without doing RDS. So these are some examples of what can be considered an anchorage or a tie-off point on your roof or on a particular level where a window washer or contractor may perform rope descent. In the upper left-hand corner is a typical pipe stanchion type roof. We call it a roof mount anchor. It's a pipe stanchion. These can be cast in place with your concrete slab. They can be bolted through, welded to steel structure, you name it. There's various ways they are connected to your structure. But simply put, it's just an anchor with a closed loop on top that a window washer, again, can tie his ropes off to before he goes over the side of the building. The anchor on the upper right-hand corner is just a wall-mounted anchor instead of it being mounted to the roof slab or roof surface itself. This is actually mounted on a parapet wall or a penthouse wall. And then at the bottom, it is not uncommon to have structure that is certified and tested. And we'll go over that certified and tested. We'll talk about that a little bit later about what that means. But essentially, the tie-off points for the lower left-hand picture is the big, large column screen walls. Every 10 or 15 feet, there's a large column you see there that supports the screen wall steel. And the actual window washer on this particular project is wrapping his ropes around that big steel column. Similar to the photo on the right-hand side, this is a cooling tower location where your mechanical equipment is posted up and supported off of the roof surface. The concrete columns, the steel beams, and the steel columns that you see that is supporting all of this HVAC equipment is certified and has been load tested as being a anchorage point. So again, the window washer can tie around the concrete columns, concrete piers, the steel columns, or the steel beams as anchorage points for RDS. When you deal with a rope descent system, there are some specific things that we need to look at as a consultant, an engineer who does this type of work. When we go out and look at a property or we look at the anchor layout, we want to make sure that it meets certain requirements, and that it meets certain requirements that allows for proper rigging, safe and proper rigging. Because in OSHA 1910-27, OSHA states that the RDS, the system, must have proper rigging. And so it's kind of a vague term for OSHA, right? It just says proper rigging. It doesn't tell you how to do that rigging. That's obviously up to the window washer. And when I say rigging, we're talking about how they're tying their ropes from one anchor to the next anchor to the adjacent anchor, and how they're getting all their equipment in line and rigged up to drop over the side. So the I-14 standard, again, that's a standard we discussed that came out in 2001. The I-14 standard is the only standard that addresses particularly the layout of anchors used for RDS. How specific and how these anchors should be laid out is addressed in the I-14, and that's the only standard out there that does that. And when you look in that standard, it basically limits what I call the swing angle, which is, you see a picture here in the right-hand corner. It limits a maximum of 30 degrees, I'm adding the 15 degrees together. It limits 30 degrees between adjacent anchors. So when I go up to a roof, when I tie off to my anchor next to me, remember when I make a drop, I've got to use 2 anchors, and those anchors need to be side by side or relatively close. They can't be more than 30 degrees apart, but they also cannot be more than 12 feet on center. And so what we're doing here is we're controlling what I call the swing angle. We're limiting the range of motion for the worker. I'll show you what I mean by that in the illustrations that I have here. So on the left, this is a plan view, bird's eye view. Imagine we're looking down on top of the roof of your building, and this is the outline or the shape of the building. The black line is the boundary or outline perimeter of your building. And our window washer is secured to 2 anchors, one line being a red line, one being the green, and then he's making his drop right here at the corner of this building. If the red line or the anchor attached to the red line was to fail while the worker was doing his drop, his body is going to naturally, the window washer's body will naturally swing across the front of the building, and it wants to basically swing to where your body is perpendicular to the adjacent anchor or the remaining anchor. And I've dashed that in with a blue line to show you how that happens. Well, the situation here, the problem here is that if that red line snaps and that green line, we call it hopping the corner or jumping the corner, if that green line was to jump the corner, which could very well happen because when the line breaks, the worker actually drops. He can drop up to about 3 to 6 feet, no more than 6 feet, but he actually drops. From the air, he'll drop a few feet until his secondary or lifeline kicks in. When that happens, he could very well jump the corner. That means the green rope jumps, and it now is out on the outer bound of the building. If the green line that has now become the blue dash line, if that is now your suspension line, you have all that excess suspension where the building returns back to itself in the corner. That person is now going to swing straight into the building facade before his fall arrest is stopped. And I hope that makes sense in the illustration here. But the idea, again, on the plan view is that if the rope breaks on red, the red line breaks, and the green rope hops the corner, then the body with the slack of rope now is going to swing into the building, and he's going to hit the building, the side of the building. The other scenario is on the right, the elevation view. Here we're looking at the side of your building. And this demonstrates what happens if, even though my green and red line were maintaining 30 degrees apart, I still maintain the 30 degrees max according to the diagram in the upper right-hand corner. But as I get down the side of the building, as I'm dropping further and further from the top of the building, you see that 30-degree angle really provides a wide range of coverage across the elevation of the building. Hence why if you look at the I-14, they tell you to limit it to 30 degrees between the ropes, but no more than 12 feet on center between the anchors. So the situation here is that even if we met 30 degrees between the ropes, again, if the red line breaks or that roof anchor was to fail, then the worker now is going to swing left across the page until his body reaches equilibrium. Based on where he is on the elevation of the building, if we assume the smaller portion of the rectangle in the middle of the building was like a canopy or an overhang or something, some obstruction that stuck out from the building, you can see that the worker's going to make contact. He's going to literally swing into that obstruction before his body is able to stop and be arrested. So we need to control those types of things, and those are some things that typically aren't looked at when you look at your anchor plan. For instance, this is an existing project in Denver we worked on last year with a client. This was an existing property. It was 3 wings, kind of a unique building, the way it was shaped here. Everything that you see here is the existing roof anchors that were on the building when ATS showed up day 1. Now, what you can't tell in this photo, in this drawing, is the scale or magnitude of this building. The roof anchors that run kind of down the middle of each wing, if you will, those roof anchors are about 20 feet on center. So we're past 12 feet on center. We're well more than 12 feet on center. So we're 20 feet on center. We can't maintain the 30-degree coverage in many places as we go around the building, because we have to there's windows on all elevations of the building. So when we went out and saw this building, we saw this layout, and we recognized the amount of equipment or lack of equipment was on this building. It became apparent that in order to do proper rigging, right, in accordance with OSHA 1910-27, we needed to add anchors. We needed to add anchors to this building. This is the design that came out after the fact of adding additional anchors. What you see here, if we go back, everything in orange was existing. We got a bunch of different colors, but essentially each new wing needed a total of about 14 new anchors. They are mixed in here, called BMs, 37, 38, 39. You can see my mouse. But each wing, a wing here, a wing B, wing A, took about 14 additional anchors to be added. In the middle of the building was large steel structure. So all the C's in blue are existing columns that we load tested and certified as tie-off points. They are basically existing structure. But essentially, what I want to drive home to you guys on this is the difference of this was what the client had, and they thought that they had a compliant layout that met OSHA requirements. But once we got on site about 1.5 years ago, we quickly realized they did not have enough anchors to have a safe and proper rigging, which resulted in the addition of the anchors you see here. And those were installed last March on the building. So before I jump into the suspended access, are there any questions dealing with rope descent systems before I get into the powered platform stuff? All right. So again, we mentioned that rope descent systems, RDS, is the most typically the cheapest, most economical way to clean your building. But there are limitations to that. For instance, if your building is over 300 feet, you cannot do RDS. But there may be other situations, even with a low-rise building, where you need to do suspended scaffolding or use a powered platform. In a situation where the work you're trying to do simply cannot be done off of a bosun's chair or being suspended from ropes, it requires workers inside of a stage working side by side. And there are ways to do this if you only have roof anchors on your building. The way to do it if you only have roof anchors on your building is shown in the bottom left-hand corner. The 2 devices that you see here with wheels on them, these are called counterweighted outriggers. The devices are brought up to the roof in pieces through your freight elevator or your stairs. And they're put together on the roof. There's some heavy weights on the back end here. These things are beams that cantilever out over the edge of your building. And at the end of the beam is where your support cables, you see here, your support cables are supporting the stage. We can't see that in the photo, but the stage is down on the ground, supported by the outrigger beams that are sticking out over the roof. This is a very common way of how you would do staging on a building, again, if you had nothing but roof anchors on the building. When you do this type of rigging, it requires at least 4 anchors. Each counterweighted outrigger, each piece of equipment here has to be tied back. You see some cables coming back. off of this equipment. So each piece has to be tied back to an independent anchor. Each worker inside the stage, so there's a stage, and then there's 2 workers typically inside that stage. Each worker inside that stage will be tied off to an independent anchor as well. And that's just a system of redundancy. If the outrigger breaks or gets pulled over the side of the building, it is tied back so it cannot fall off the building. If the stage is upset or it fails or the cables that support it were to fail, the workers in the stage do not go to the ground because they are tied off with fall protection to independent anchors on the roof as well. And so that's your setup for counterweighted outriggers when you have anchors on them. The upper right-hand picture is using a power platform stage, but in this situation, the building itself actually has davit bases. You see these pipe stanchions, larger pipe stanchion structures sticking up. They have these installed on the building. There's a socket, which is the device here, that actually connects to the base. This socket is basically a female type receptor that allows the davit arm, the upside down L structure, I like to call it. This davit arm inserts into the socket. The socket attaches to the base. And then this is how your suspended platform is supported on a building. With this particular setup, this is called roof rigging. So what they're doing here is the platform is being set up on the roof. It's being built and constructed on the roof. The workers get in the platform on the roof. It is picked up, and then it is swung outbound from the building exterior, and then it drops down to do the work, and then back up in the reverse procedure. Is the reverse procedure. That's called roof rigging. For ground rigging, it's the opposite. The actual stage, similar to the photo down here, the stage starts out on the ground and is picked up from the ground and is brought up the side of the building. And there are limitations of when you can and cannot do roof rigging and ground rigging. We'll go over that in a little bit. But keep in mind, if you have a building under 100 feet or so and you have staging on it or you have davit bases, this is typically going to be what's on your roof. And then you get into the more fancy stuff over on the right-hand side. This is what's referred to as a building maintenance unit, a BMU. You guys may have seen this particular unit lurking among the tops of the Optiv building in downtown Denver. This is the machine on top of the Optiv building there in downtown Denver that is responsible for washing the windows and maintaining the exterior facade. These types of machines are required when you get it 500 feet from ground. Once you get, the number is actually 490. Once you get 490 feet from the ground, all of your electrical, mechanical, all your motors, your mechanized stuff has to be put on the roof and permanently installed there. So essentially what you're looking at is a big mobile crane that sits on top of this building. It rides these rails that you see here. So it will traverse in and out of the page towards us. It spins 360 degrees, and it also booms out. This is the contracted position. It masts up, so it goes up, and then this boom will actually boom out to around 70, I believe it's around 75 feet or so. Excuse me. But again, something like this is only required if you're 500 feet from ground. So when you do power platform setup, when we talked about the RDS, we talked about it was very minimal equipment. You only needed roof anchors, your window washer brought harnesses and ropes, and the additional equipment required to attach to that roof anchor. With power platform equipment, it's a little bit more complicated in that you have davit bases. Then you typically have a socket, which we talked about, that connects the portable davit arm to the actual davit base. Then you have a set of portable davit arms. Most cases they're portable. They can be permanent. The difference in portable and permanent is that a portable arm cannot have more than a reach of 8 foot 6 inches. That is an OSHA requirement. If your davit arm has more than an 8 foot 6 inch reach, and what I mean by that is the short leg of the L. If this boom sticks out more than 8 foot 6 inches, it's considered a permanent davit arm, and it must stay out on the roof. It cannot be transportable. It must stay locked to its base, and it simply just lays down on the roof when it's not being used. For most cases, that's avoided for many reasons. But again, if you do have a permanent arm, it's because it is over 8'6" and it has to stay fixed to the base. Other requirements of a portable davit arm is if it weighs over 70 pounds. We see this a lot, particularly out in Denver with some of the older equipment systems on the building. But when a portable davit's over 70 pounds, it has to have wheels. This is to facilitate the transport from one location to the next. And it can't weigh more than 300 pounds when it's fully assembled. We talked a little bit about the ground rigging and roof rigging. There are some differences there in that ground rigging cannot be done over 130 feet without stabilization. And we'll show you a picture of that here in a second on the next slide. But this thing is basically a power platform is basically a large swing on the side of your building, a large pendulum. So once, the more the depth of the drop is or the height of the suspension, the more unstable this platform can get. It's a large swing essentially on the outside of your building. So OSHA has some ground rules that you have to follow when you do ground rigging or roof rigging. And when you're 130 feet or less, you do not have to stabilize your platform. This means essentially your steel cables go all the way to the ground 130 feet, and they support the stage, and they can bring it up to the roof or to your level at 130 feet. Once over 130 feet, if you choose to do ground rigging, your contractor chooses to do ground rigging, you have to use continuous stabilization. And that's usually a track system. And usually when you're over 130 feet on your drop, again, up to that 490 foot rule that we were talking about for BMUs, if you're over 130 feet of your drop, then it's typically, you have to do roof rigging. You have to stabilize yourself as you come down the building. And I'll show you a picture of what that looks like. So on the right, upper right-hand corner, the stage has come down from the building. This is a shot looking back up. The bigger wires that you see here, bigger black cables, are the actual main suspension cables that are supporting the stage. These smaller little steel cables that you see here are actually steel lanyards that are tying in about every third floor on the building. As the stage comes down, the window washer, the contractor inside the stage, during a roof rig drop like this, During a roof rig drop like this, the window washer is looking for what we call the ISA, the intermittent stabilization anchor. There's various types out there. The particular type on the left-hand corner here, upper left-hand corner, is a female type receptor. It is basically a little tiny hole in the side of the curtain wall. About the diameter is about the size of your pinky, 3/8 diameter, very small, very hard to see unless you know what to look for. But these are strategically placed where the drops of the suspended scaffold are going to go, and then you tie yourself in as you come down. So this little steel lanyard lassos around the main suspension cable. There's a detent pin with a male connector that actually connects into the female receptor of the building anchor. And then this lanyard gets tightened or gets tightened up. And that's what keeps the cable from swaying back and forth across the front of the building. That's your stabilization to keep the platform from getting out of control on a windy day. Another example is the photo just below this. This is a different type of intermittent stabilization anchor. Some people call these buttons because they stick out like a button, or they call them mushroom caps. But again, you can see these are little stanchions, little pieces that stick out on the curtain wall all the way down the building. And as the platform comes down, again, you can take these steel lanyards and lasso them or pull yourself into the building. Or sometimes there's an actual what's called a guide shoe on the platform that will slide over this male connector and allow the platform to tie into the building and again, stay stabilized. The picture on the upper right-hand corner, this is actually off of the U.S. Bank Tower there in downtown Denver. I was down there a couple weeks ago doing a facade access study on that building. This building uses the continuous track system for stabilization. So each one of these little arrows, this is actually the vertical mullion system of the building. You can walk right by the building and look at this on the outside of the building. But this is basically a little, you can see a little gap in here on each one of these mullions. And so there's a device, again, called a guide shoe that slides into this track, into this channel, this groove, and then it ties itself to the platform, and that allows the platform to stay locked into the side of the building as the platform traverses up and down the building. So again, this is an example of a continuous track stabilization. And we call it continuous because, again, the guide shoes lock in to the platform, and the platform continuously stays tied into the building as it goes up and down. Whereas with these other methods over here on the left side, we're tying in intermittently, even after 8 years, that's so hard for me to say, intermittently every third floor as we come down the building. And then on the right is just another version as well of a stabilization system. This mullion actually sticks out and engages the platform as it comes down from the roof. And it's located in strategic locations at each end of the platform. So that's your stabilization for powered platforms. Our question 2 is, now that we've covered RDS and suspended access methods, what method is used most often to maintain your facade of your property?
Go ahead and enter your answers. I'm going to turn it off in a second. There are your results.
Okay, so it looks like we're a little all over the board. We've got one person here who has either a powered platform or maybe they have a BMU, probably staging though. RDS for 50% of you, 3 out of the 6. And then there are a few that may just possibly have like what I call a low-rise building, 3 or 4 floors or maybe less, and you're probably doing cleaning with telescoping poles or an aerial lift. Okay. We covered the equipment. We covered the equipment and the methods for building maintenance, for window washing particularly. Now I want to talk a little bit about fall protection equipment. The anchors and the davits and all that used for suspended access are all part of fall protection equipment. But there may be cases on your building where, like the few that had answered the poll, that you don't do RDS and you don't do powered scaffolding on your building to maintain it. Maybe you have a horizontal lifeline though, or a vertical lifeline system on your building for gaining access to some areas because of fall hazard situations. So just want to go over those equipment types and the federal regulations and standards on that as well. So with fall protection equipment in general, that's covered under the OSHA 1910-28, the duty to have fall protection as an employer, and also covered under 1910-140 for personal fall protection systems. And then the standard behind that, those 2 regulations, and the standard where a lot of that comes from is the Z359 standard. So why do we need fall protection? So a lot of times we're approaching, we're on a low slope roof, or we could be on a any type of roof really, but we're approaching an unprotected roof edge. Unprotected meaning it does not have a parapet that is at least 39 inches or a guardrail at least 39 inches tall that could prevent someone from falling over the side of the building. So that's what we mean by unprotected roof edge or unprotected edge. It could be a hole in the floor, It could be an opening, such as a cooling tower well in your roof. It could be a skylight. If you have skylights on your roof and you're walking within those areas, or you're working within those areas, then you are definitely you could be in an unprotected fall hazard situation, even when you're working around skylights. In order for you not to be in a fall hazard situation around skylights, the skylights must have been designed to handle a person falling into them, or must be rated for a walking surface, which most skylights are not. So just keep that in mind if you do have skylights and you have any type of equipment where you're working near those skylights, you may need fall protection. If your fall is greater than 48 inches, OSHA says that you need to have fall protection. Roof hatches, those are often fall hazard situations, almost always because the habit is, even for myself, going up on roofs all the time, is you go up, once you exit the hatch, you walk away from it, and there's a hole in the roof. We typically never close that hatch for whatever reason. We don't want to get stuck out on the roof, or the fear that hatch may get locked and leave us out there. And again, I know I'm one that does that all the time. But again, just keep in mind, when you do exit that roof, if you leave that hatch open, that is now a fall hazard situation, and needs to be addressed accordingly. And then fixed ladders. You also may have fixed ladders at your facility. We're talking about the ladders that are bolted onto the side or welded on the side of your structure. They most likely will have a fixed well or a cage around them, a cage ladder. Keep in mind that as of 2017, when this regulation, the 1910-28, this fall protection regulation was revised in January 2017, that they updated fixed ladder requirements, in that if you have a fixed ladder, if you have a fixed ladder that is over 24 feet or greater, you are now required to have a personal fall arrest system on that ladder. And what that means is a vertical lifeline system. So your caged well or your fixed well on the outside of the ladder is no longer compliant if you're over 24 feet tall. You have to retrofit that ladder with a personal fall arrest system. One thing I did want to point out is, when you are dealing with unprotected roof edges, in 2017, when they revised this fall protection regulation, OSHA actually put a number on when you have to have fall protection. Previously, it was always kind of understood that if you were working within 6 feet, some people said 6 feet, some people said 8 feet. If you were working within that close of a zone of the edge of your building, then you needed to have fall protection. OSHA never really gave you a nominal number, or really defined that number, until a couple of years ago. Now, if you are working within 15 feet, or closer to an unprotected roof edge or a fall hazard, you are required to have a fall protection system in place, whether it be active or passive. So keep in mind, 15 feet, I call it the 15-foot rule. That's now the boundary, if you will. 15 feet or closer, you have to have fall protection. It's not 6 or 8 feet anymore, as other people used to use. So I mentioned there are types of fall protection systems. There are active and there are passive. Active are those that are fall arrest systems or fall restraint. Again, these are all fall protection systems. The verbiage of fall arrest and fall restraint describes what the system particularly does. A fall arrest system is designed to protect a worker from actually hitting the level below. So it does, well, what we call it, we arrest the fall, we stop the fall. So in a fall arrest, a fall protection system that has been designed for fall arrest, it is in a system that is actually stopping or catching the person in the air once they have made, or once they have gone over the unprotected edge. They have basically fallen, and now we're stopping that fall and keeping them from hitting the ground below. That is a fall arrest situation. A fall restraint is another type of active fall protection system. But in a fall restraint, we are actually preventing the worker from actually reaching or actually being able to step over or actually being able to fall from that unprotected edge. And the way that is accomplished is typically by using a fixed lanyard or a fixed rope, so that basically when the worker gets to the end of the lanyard or the end of the travel of the rope, there is no more distance or available distance on that lanyard or rope. They cannot take a step further to step off of the edge of the building. So we're actually restraining them. We're tethering them back from actually ever being able to fall. That is called a fall restraint situation. And so both of those systems are considered active fall protection systems. Your other option would be fall guarding, which is a passive system. And it is simply just putting up guardrail or a type of structure in place that would prevent the person from actually accessing the fall hazard area. And it's most commonly done with guardrail, guardrail and handrail. So question number 3, when accessing a low slope roof, whether it's active or passive, it's required for any personnel when working a minimum distance of how many feet from the roof edge. So now if you're working on a low slope roof, the minimum distance in feet, before you have to have fall protection, is our question here. All right, so the 4 that answered correctly. 15 feet is the rule. So good job on that. All right, so these are just some examples of fall protection systems. The upper 2 pictures are cable systems, horizontal lifeline systems. They work very much the same. They have the same purpose. They look a little different. Over on the left-hand side, you see 2 shuttles here, one for each worker. The worker attaches his lanyard, attaches his lanyard to that shuttle, and that shuttle allows that worker to travel freely up and down the line without having to disconnect. This is called a hands-free system. Similar as the system on the right, the shuttles are in black here. They will do the same thing. You hook off to the shuttle, and then you have to walk the steel out here to traverse the line as you go around this cooling tower area. The red arrows, what I wanted to indicate here by the red arrows, if you guys have cable systems on your properties or buildings, if you have horizontal lifeline systems and a cable system, most cable systems out there will have an energy absorber that is installed in line with the cable, and that's what is shown in the red arrow. Different manufacturers, they all look different. You can see the version on the left, the version on the right is basically coiled up. It's a coiled up wire. There's actually 2 of these on the one on the right. Excuse me. And so based on your system requirements, how the system was designed, meaning how many workers can access the system at one time. Is it 1, 2, 3, or 4? But based on all the design parameters and the system itself, the manufacturer determines how many energy absorbers are required. And what these energy absorbers do is if there's a fall that happens on this cable, this energy absorber stretches out. And it does exactly what it's described. It absorbs energy from the fall or from the impact of the fall, and it lessens the load or lightens the load that is actually distributed on the cable and essentially back to the termination anchor that hooks to the structure. It dissipates energy. So that's how a cable system, a horizontal cable system, works. The 2 systems at the bottom, the lower left-hand corner, this is a vertical lifeline system. So this is same as a horizontal system. Instead of walking a surface here, we're actually climbing a ladder vertically, and you see the surface, or you see the cable system in the center of the ladder. In this situation, the worker hooks off to the shuttle or the traveler, of the cable. And then he hooks off to his chest D-ring on his chest of his full body harness, and then he climbs the ladder. If there's a fall arrest situation, this traveler will lock up and prevent them from falling to the ground. So that's a vertical lifeline system. Again, they're now required for any fixed ladder over 24 feet. And then over here on the right.
Hey, Kevin.
Yes, ma'am.
Yes, we have a question from
Okay.
Daniel Wiseman. He says, regarding the 24-foot requirement on fixed ladders, this applies to existing ladders, and is there a timeline for when the required protection needs to be installed?
Yes, it applies to existing ladders for existing properties. You have until November of 2036. So you have a little while if you have an existing ladder. But you have until November of 2036 to make your ladder compliant. That answer the question?
Yes.
Okay. All right. So what I wanted to point out on this next slide is very important if you have a cable system. This actually came up recently with a client, one of my clients in Florida. Kind of had to educate them a little bit on cable systems. It's a new project. A contractor installed a cable system and basically called ATS to come out and certify the system and say that it was good to go so they could turn the building over to their owner and allow them to use it. What we found out as we dug into the system that was installed is that they do not have the proper height clearance to use the system. And what I mean by that is your worker in this scenario, the worker or the working area that he is at is where my mouse is. If you guys can see that, it's where my mouse is. And in order to determine the height clearance, there's a lot of different variables that the designer has to look at. One is the sag of the cable. How much does that cable that we talked about stretch out? That energy absorber stretches out. Along with that, the cable system itself stretches to dissipate energy. But depending on what the worker is attaching his body harness to the actual system, will provide additional sag. And there are two ways that he can do that. He can attach to the system using this is called an energy absorbing lanyard. This is a 6-foot lanyard. He hooks one end to the body harness, the other end hooks to the actual cable system or fall protection system. In the event of the fall, this is what we see in this scenario on the far left. In the event of a fall, the cable system stretches as well as the energy absorbing lanyard. So where this lanyard is 6 feet, when the person falls, this webbing in here stretches out to another 6 feet. This thing doubles its length in size when there is a fall arrest situation. Okay, so you have the sag of the cable plus an additional 12 feet. You got to add all this up and make sure that you have enough clearance so that when I fall off of my level up here, my working level, I don't hit the ground or lower level below. The other situation, we have a self-restraining deceleration device, or some people call them a self-restraint lanyard. Sorry, hit buttons over here. This is the device on the far right, at the bottom of the far right. This device works completely different than the device at the top. The device here at the bottom, the SRL, self-restraint lanyard, or self-restraint device, SRD, works very much like a seatbelt in your car. This has a coiled up cable inside. As long as you are not making sudden movements or jerks, this cable will come out freely, just like the seatbelt in your car when you go to fasten your seatbelt every time when you get in the car. If there is a sudden movement or jerk or obviously a fall, a quick jerk in this cable system, then it's designed to lock up like your seatbelt and prevent the cable from extending any further out of this housing. With these types of devices, your clearance requirements is a lot less, as you can see indicated in the pictures here. The two purple scenarios are just showing you what happens if this cable system is installed using a lanyard and the minimum clearances you need for that. Meanwhile, with the deceleration device, some people call these yo-yos in the fall protection industry. With a yo-yo device, this situation and the last situation are possible. And you can see that the clearance requirements are a lot less. What I'm pointing out to you is to understand that if you have a fall protection system, a cable system on your property, that you are fully aware of the minimum height clearance that you need if there's a situation of a fall arrest situation where somebody steps off of the building or steps off of that upper roof onto the lower surface so they don't hit it. You understand whether the system, in order to be safe and used properly, has to be connected using either the fixed lanyard here, or if it has to be using an SRD or an SRL. This all has to be looked at going back to the manufacturer's requirements. And again, I just thought this was very helpful to bring up this week after having had a discussion with another client this week that they installed a horizontal lifeline system and they're trying to access doing mechanic work on planes, and they're only about 10 feet off the ground. And when you look through the literature of this system, it doesn't matter if you use the lanyard or the SRL, where you can have a shorter clearance height. Essentially, with the system that this client installed, whether they used the lanyard or the deceleration device, if somebody steps off of that plane at 10 feet from the ground, they're going to hit the ground before the cable and everything stops them. So it's very important that you understand, if you have a cable system, what's the height clearances required, and specifically what components, what safety equipment, what PPE, personal protective equipment, does the worker need to attach that system to work properly. Other types of fall protection system, and these are the passive systems we talked about, is the guardrail systems. This is guardrail installed over a roof hatch. Here, as you can see, we left the roof hatch open when we exited. The guardrail prevents workers from walking by on the roof and falling into the hole. Same situation over here. This is just a smaller version of a roof hatch. This is a skylight where we installed some guardrail around skylights. Obviously, you could not work on this you could not work on the HVAC equipment in the back without having some type of fall protection, just due to the proximity of the skylight. This is a fixed ladder with the cage well we were talking about. Again, if you're over 24 feet, you need a vertical lifeline system now. Our fourth question, and I just gave my answer away here, but hopefully I drilled home to you guys that, again, if you're over 24 feet, you do need that vertical lifeline system. I think everybody seems to be getting that question. All right, and then we get into, just briefly, I'm not going to kind of get through all the technical jargon, if you will, of the design of the equipment. Just some things that you guys as property managers, facility managers, building engineers need to know. When you deal with personal fall protection systems, the anchorage of the system, this is where the cable anchors back. It's where that cable anchors back to your structure, but that anchorage needs to be designed for 5,000 pounds. That's an ultimate, or I like to call that a failure load. And that's if the system is not designed by a PE. This is for a cable or a horizontal lifeline system. It could be a rigid rail system either as well. But we're addressing fall protection systems, not suspended access equipment. If a PE is involved, the system can be designed for a safety factor of 2 to 1. And then, of course, whenever you do have a fall protection system, there should be a tag on your system. And we look for this when we come out and do your annual inspections. But the manufacturer's tag should list on there the type of system. In other words, is it designed for fall arrest or fall restraint? How many workers is allowed on the system at one time? There may be some other information as well. But those are the two main things that we want to know or we're looking for. Because again, that describes to the user of the system, before I attach to that system, is this a fall arrest system and fall restraint? That right off the bat ought to tell me what type of equipment, additional PPE I might need. And then again, how many workers are allowed to be on the system at one time. When you deal with suspended access equipment, the tieback anchors we discussed for RDS, those have to be designed for a minimum 5,000 pound ultimate load. Again, I call that failure. The davit bases, sockets, and davit arms must be designed for a minimum safety factor of 4 to 1. So in this situation, davit arms typically have a minimum load rating. Another word for load rating or rated load, I call working load. So this is the maximum load that the manufacturer will tell you that can be put on a davit arm for suspending the scaffold, or the maximum load that can be put on a tieback anchor. And typically that's 1,000 pounds. Meanwhile, the engineering, the design, the engineering, the whole aspect of the connection to the building and taking responsibility of that design, everything's been designed for a minimum of 4 to 1 safety factor. So, for example, if your davit arm or your davit base is supposed to be designed to handle a 1,000 pound working load, then the engineer of record, like myself, would have designed the davit base and the davit arm to handle 4,000 pounds minimum load. And again, that's a failure load, the 4 to 1 safety factor there. Any questions on the design of the equipment?
I don't see any.
Okay. So when you have all this equipment on your building, hopefully you guys are all aware that, and you're performing annual inspections. OSHA requires that all of this equipment be inspected annually, at least once annually, before any contractor or window washer uses it. Initially, you're going to do, you should have an initial certification. That's also a load test, where we're physically loading the equipment. You see the picture in the upper right-hand corner. This is an example of testing a tieback anchor, where we're actually physically pulling this anchor up to 2,500 pounds. So you should have an initial certification on file with the property that shows that the equipment has been load tested and certified. Typically, we like to see that done by an engineer, or we recommend that be done by an engineer, at least the oversight of the certification, and that you have a stamped report by a professional engineer. Every 10 years, OSHA requires that load testing be reevaluated, and that's called recertification. So every 10 years, or if you're re-roofing around the equipment, you need to do load testing after the equipment. When we do load testing, we're typically load testing the tieback anchors to 2,500 pounds. That is half of the ultimate or failure load that they're designed for. That is actually a prescriptive test method that comes out of the ASME A120 standard that we use as a guideline. It's also in the I-14 standard as well as a prescriptive method on how to test roof anchors. When we test the equipment, we're also, you see the equipment here has a dial gauge in the upper right-hand corner of the photo. There's a dial gauge on the left. This is measuring deflection. We want to see that there's been no permanent deformation. In other words, we didn't bend anything. Excuse me, we didn't bend anything or deform anything permanently. And when we test davit arm assemblies, this davit arm assembly includes the davit arm that you see here in the lower picture, the davit arm, the base of what's connected to the structure, the socket, the whole assembly, if you will. When we test that, we're actually testing to 2 times the rated load. So again, if your davit arm is rated for 1,000 pounds, we're going to physically load that for 2,000 pounds, 2 times that rated load. Keep in mind that it has been designed by an engineer with a safety factor of 4 to 1. With fall protection systems, they are also required to be initially tested. And we're talking about your cable systems, your horizontal lifelines, vertical lifeline systems, active fall protection systems. They should be initially tested and certified, again, under the direction of a professional engineer. They're also required to be visually inspected daily before you use them, but they also have to be documented for an annual inspection. And that's required by OSHA and as well in the standards. The Z359 fall protection standard recommends that load testing and recertification be performed at least every 5 years, no more than every 5 years. It could be more if that's specified by the design professional who actually designed the fall protection system. But in no regard should it be more than 5 years between the recertification and load testing of a active fall protection system. And then just dealing with some terminology here, personnel using fall protection, personal fall protection systems should be properly trained and competent. So there are terminology of a competent person, which is a competent person is somebody who's been trained or has the experience, which is knowledgeable. Then there's a qualified person, which is one that has been recognized with a degree or professional certificate or extensive knowledge. So keep in mind, because a competent person can use the system. A competent person has to be trained to use the system. But the system should be designed by a qualified person and should be inspected and certified by a qualified person, which, again, and our recommendation would be a professional engineer. Just some things that we do for inspection and testing methods. For the typical annual inspection, it's typically visual. There's also a sounding inspection that we do. Visual, obviously, we're checking for corrosion, loose bolts. We take a rubber mallet. We actually strike the equipment. We strike the davit base, or we strike the tie-back anchor. Different equipment will emanate certain sounds. We listen to those sounds as we go from one piece of equipment to the next. If the sound changes, that's usually a sign that something's different, and usually kind of red flags things that we want to take a closer look or investigate things a little bit closer. That's typically what's done for our annual inspections. Again, if we find something that raises a red flag, we may recommend additional testing, non-destructive testing. Those can include several things where we're checking welds using liquid penetrance and ultrasonic thickness testing, bolt torque verification. We want to make sure that any bolts, nuts, connection hardware has been torqued properly. And then sometimes with the powered platform equipment, obviously with the BMU type stuff, we're actually doing operational tests as well. This is an example of a davit arm load test. We're doing it right out on the roof of the building here. You can see we've taken the sockets, inserted the davit arm into the socket here, which is the rusty fixture. We've actually bolted these two fixtures together, or tied their ends together, and we're pulling the davit arms against each other. So here we're checking this, again, this assembly, davit arm, davit socket. We're checking this whole range of motion as we load it up in the field. This is how we would test the davit base itself. So the base is this portion of the structure that's attached permanently to your building. We create or fabricate a fixture that attaches to that permanent base. We have an aluminum beam fixture and a hydraulic pump. We're simply pushing up with a hydraulic load. We're pushing up on this beam. And what this allows us to do is mimic the the loading that the davit base is going to see from the davit arm when it supports powered platform. So our polling question for number 5 was, with davit bases, davit arms, basically the davit arm assemblies, we are load testing to how many times the rated load or the working load, manufacturer's working load.
Go ahead and mark your answers. I'm going to turn off polling.
Looks like for the 2 that responded, they had that correctly, so a good deal on that. All right, so this is just an example of load testing tieback anchors. And again, they come in all different shapes and sizes. But again, we're simply just wrapping straps around the tieback anchors, adjacent anchors, and we're pulling them together with a winch. The dynamometer here in the middle measures the tension in the line. And then you see the dial gauges at the end where we're measuring deflection and capturing that data as well. Just another example of how we may test an anchor. This particular anchor is flush mounted. So we're using this device to actually pull straight up as opposed to pulling it side to side with an adjacent anchor. So our 6th question, this is our final polling question, is OSHA requires that anchorages used for RDS and their structural elements to be designed for what ultimate load, what failure load?
Go ahead and use the chat box. I don't think my poll for this one saved.
Okay. Whoops.
Looks like we've got 5,000.
Okay. And that is the correct answer. Yeah, hopefully nobody put 36. Sometimes you'll see 36 on fall protection. Don't want to try to confuse you, but if an anchorage point is not used for RDS, again, RDS, rope descent systems, where we're specifically hanging over the side of the building, suspending ourselves for some type of maintenance. If a single anchorage point is used for fall protection, such as to tether somebody from falling over the side, and it is not specifically used for RDS, remember as we were discussing some of the design aspects for fall protection system, if a fall protection system is not designed by an engineer, then the anchorage point has to be designed for 5,000 pounds. If the system is designed by an engineer, you can get away with a safety factor of 2 to 1. So, again, I'm trying not to confuse you, but a body harness, when you do fall protection design, OSHA and the standards state that you cannot, the maximum a person's body can see during a fall arrest situation is 1,800 pounds. That's called the maximum arresting force. That's the maximum force that can be exerted on the body, 1,800 pounds, when a person is in a fall arrest situation. And so if that's the maximum force exerted on the body, and I design a system for a safety factor of 2 to 1 as an engineer, then 2 times 1,800 is 3,600 pounds. That's where this number comes up from. So if you have a single anchorage point on your building that is used for fall protection, not rope descent systems, it's for fall protection only, there is a chance that it could have been designed for 3,600 pounds by an engineer during at some point during that equipment being installed or designed. But again, if it is used for RDS, specifically to suspend a worker for building maintenance over the side of the building, it has to be designed for the minimum of 5,000 pounds. So just want to point that out. And then, of course, why we load test. This was a typical anchor. And then you can see what happened. You know, we typically did a visual. Again, we do our hammer sounding test. Obviously, over several years of doing that, that did not determine the same results as what happened when we actually physically load tested it with our test fixture here. And so to bring this to the conclusion, just some things that are required by ownership. When I talk about ownership, the building owner or property manager, these are records that you guys should have and keep on record with the building. And so you need to maintain, your initial certification we talked about. You need to have that report that can go back as far as 10 years ago. Because again, every 10 years, you're going to recertify and load test the equipment. So you should at least always have a certification report that shows the last time the equipment was load tested and certified by a PE. And specifically, OSHA states that if you are using anchorages for RDS, in the RDS regulations, 1910-27, they actually state that the building owner has to inform the employer in this case is the window washer, that the building owner has to inform in writing that they have identified, tested, certified, and maintained each anchorage that is at least capable of supporting 5,000 pounds in any direction. And again, it goes on to say that you have to do that as well as every 10 years. Some other things that you need to maintain that a lot of property managers don't know about is the records of the equipment themselves. For instance, the manufacturer's operating and maintenance manuals. There's a lot of information in those manuals that describes how the equipment should be set up, inspections that should incur daily, monthly, certain routines of inspections that need to occur. There's authorized personnel training logs. Hopefully you guys are all aware that everyone that uses the equipment on your building has to be trained, and that should be documented accordingly with the building records. So if you have a horizontal lifeline system on your building, you need to have an authorized personnel training log that shows that the contractor coming on site has been trained to use that system properly. Not only trained to use that system properly, but he understands that he has to use that system with a self-restraint lanyard or self-absorbing lanyard versus a self-restraint deceleration device. It's kind of your CYA, if you will, cover your butt documentation, that at the end of the day, if there's an incident on your property that happens and OSHA is called out, some of the first things they're going to start asking you as the building owner, property manager, and the window washer, they're going to start asking you guys is, where's the information that I've listed here in this last paragraph? Where's your operating and maintenance manuals for the equipment? Where's your personal training log? So where do you show OSHA that the individuals that were on that equipment were truly trained to use it accordingly for that specific system? Where are your daily inspection records? Because the minute OSHA looks into maintenance manuals or operating and maintenance manuals and they see that the manufacturer says, oh, you need to inspect this equipment daily, they're going to come back to you as the building owner or the window washer and say, hey, where were you following the maintenance manual? And a big one is secondary brake test. If you have a powered platform, if you own the powered platform on your property, you're required to get a secondary brake test performed at least annually, once a year. And that's a OSHA requirement. If your contractor, if your window washer is bringing your platform on site, then it is in your best interest as the property manager or building owner to make sure that you get a copy of documentation from your window washer showing that he is having the secondary brake test performed annually. That secondary brake test is important because there are two sets of brakes on hoist motors that support suspended scaffolding. There's a primary set, secondary set. If the primary set fails, the secondary set have to kick in, and they essentially keep the platform from falling to the ground. So it's a crucial component that you have to have tested once a year, and you need to have that documented in your files to show that my contractor is bringing his platform and that he has done this test, and you crossed the T's and dotted the I's. Most property managers that I've run into or we talk to seem to think that their responsibility starts and stops with just making sure they've had their annual done and that they've got an annual inspection of their equipment, and they can turn that report over to a window washer to say, hey, my equipment's been looked at and it's good to go. But in reality, there's actually a lot more due diligence and record maintenance that you guys should be doing. And we can work with you on that as well, and help you get those records and stuff straight. So for the user, and again, the user in this situation could also be yourself. If you're the building engineer who uses that cable system, you also, at that particular point, if you're using that to gain access to rooftop equipment or what have you to do your daily job, then you also need to be listed somewhere as an authorized person trained to use that system. So again, the user, whether it's the building engineer or the contractor coming in, they need to be familiar or become familiar with the manufacturer's operating and maintenance manuals. They need to make sure they're listed on the training log. That there's a log there that says they've been trained and their name is on that log. They need to be aware of daily inspections and what's been going on in the past. It's always a good idea to look back at the last week or two and look at the inspections, look at the notes, look at what the other users of the system are finding or noting about the system to see if there's anything you need to be aware of before you use it. Yeah, here's another one, this plan of service. The plan of service is very important, and this is a requirement that OSHA says that you need to have with your documents. The plan of service is developed by the contractor, or in this case, the window washer. The plan of service is essentially, how am I going to access the building facade or the areas that I'm going to clean? What equipment am I using? How am I attaching to that equipment? It's also a roof map that lays out specifically what drops around the building perimeter and what equipment I'm going to tie off to. It is a cookbook, if you will, a cookbook descriptive plan of how the window washer is going to accomplish his goal of gaining access to maintaining your facade. Within that plan of service, the window washer is also required to have dictated and spelled out an emergency procedure for rescue. And I can promise you that if there is an incident on your building and OSHA comes out, one of the first things they're going to ask you and the window washer is, where is your plan of service? And let me see your emergency procedures for rescue. And if you don't have those, then it's going to be a big uh-oh. I can just tell you, because we deal with clients who call us after the fact. I can't name properties and I can't name clients, but we get calls where there were situations where the equipment did not work properly and the window washer had to be rescued outside the building for whatever the reason was. And so we get hired by the client to come in and troubleshoot. Was this really an equipment error or situation with the equipment, or was this a user error, or what happened here? So we're involved from a legal standpoint to understand, hey, how could this have been prevented, and what could we have done to prevent this from happening in the future? And in those situations, when we come in, we're working alongside the client or the property owner, the window washers, OSHA. We're involved with those different entities of trying to put together the story of what happened and why did we have this situation where we had to rescue someone outside the building. And like I said, in every situation, it is always asked, where's the plan of service? And I'll be, it is most likely than not that most property managers do not have a copy of their plan of service, or do not have a copy of the plan of service that the window washer intends to use on their building. And understand.
Hey, Kevin?
Yes, ma'am.
I just want to let you know, we're out of time, but
Okay.
If anybody that's left on this call has questions, you can feel free to reach out to me. Kevin, I don't know if you want to scroll to the last page there that's got my contact info.
There we go. I was right at the end anyway.
Yeah, sorry. Yeah, we're just a little bit over, so want to let people
Yeah, no problem.
go. But yes, if anybody on this call has questions, please feel free to reach out to either of us. Again, I'm local here in Denver and can always come out and meet you at your site and discuss what your site might need for full compliance. So thanks to everybody for being here.
Yes, thank you.
Yes, thank you. Kevin, that was great information. I want to thank everybody for joining us. I encourage you to register for our upcoming golf tournament on September 3rd. It's on our website, ifmadenver.org. And thanks to all of our annual partners. If you have questions, please reach out. Have a great day, everyone. Bye-bye.